In our last lecture, we were discussing about fundamentals, basics of propositional logic. जिसमें हमने logical connectives देखे, logical operations, implication was one most important thing. If P then Q. अगर हमारे पास hypothesis होता है तो फिर उसका conclusion भी होना चाहिए. If P then Q. फिर उसके हमने variations देखी कि हमारे पास inverse, converse, contraposition और negation of implication होती है. And then in last lecture we were discussing about quantifiers, quantification, universal quantifiers and existential quantifier. कि हम अपनी proposition को quantify करते हैं कि implication या हमारी proposition, let's call it proposition, कि हमारी proposition true है या तो तमाम values के लिए true है, then it's universal quantifier, or at least there exists something for which it is true, so that that is existential quantifier. So today we are going to discuss about proofs and basic proof techniques. Whenever we claim something, so we have to prove it. जब भी हम कोई चीज claim करते हैं, हम कोई statement देते हैं, तो in our scientific community we have to no one is going to believe it unless we give a proof to it. Proof क्या है कि हम arguments देते हैं, logical arguments, mathematical arguments, logical arguments to support our claim. जो हमारा क्लेम है कि क्लेम क्या होता है कि हम कुछ प्रोपोजिशंस दे रहे हैं कि अगर ये प्रोपोजिशंस हैं तो फिर ये स्टेटमेंट्स हैं, ये प्रोपोजिशन है, तो फॉलोइंग दीज स्टैंडर्ड दीज सेट ऑफ आर्गुमेंट्स वी शुड रीच टू सम कंक्लूजन. सो इट्स काइंड ऑफ इम्प्लीकेशन कि अगर हमारा ये हाइपोथेसिस है, सो वी शुड रीच टू कंक्लूजन, और रीच टू कंक्लूजन के लिए वी हैव टू फॉलो सम लॉजिकल स्टेप्स, some mathematical steps, some logical steps, some basic facts, some facts which are known to everyone. So जब भी हम कोई प्रॉब्लम को सॉल्व करते हैं तो प्रॉब्लम सॉल्यूशन is given by a proof. So proof इस तरह का होता है कि nobody is going to challenge it, everybody is going to accept it, because we have given our logical arguments in such a way that everybody is convinced, yes, this is true. So whenever we are going to build up some algorithm for solution to a problem, so we have to discuss about its correctness of our algorithm, और correctness को हम कैसे show कर सकते हैं, by giving a proof of our solution. So proof process क्या है कि हम कुछ assumptions पे चलते हैं, we take some assumptions, we take some hypothesis, and we have to reach to our conclusion. So in between we are going to use some logical steps. From assumptions we follow some logical steps. These logical steps could be some definitions, mathematical definitions, logical definitions, some basic facts which are known to everyone, like 2 + 2 = 4. It's known to everyone, we don't need to prove it. So या कुछ ऐसे हो सकते हैं already proven, some results, some equivalence, some other theorems which are already proved, so we can use them to support our argument. And there could be some other statements, some logical arguments. This could be some arithmetic statements, कुछ algebraic statement हो सकती है. So at the end we should reach to our conclusion. So इस तरह की चीज हम high school में करते रहे. When we are given like some we used to like have a right hand side and left hand side. We start from left hand side and we reach to right hand side. So दरमियान में हम कुछ algebraic steps, कुछ arithmetic operations करते हैं. So we start from left hand side and we reach to right hand side, and we say at the end see left hand side is equal to right hand side. We are proving like trigonometric identity, some other basic algebraic formula. वो जब हम prove कर रहे होते हैं तो हम left hand side से start होकर right hand side तक उसको prove कर रहे होते हैं. So the proof process, we are taking some assumptions. If the assumptions are correct, then we follow some correct logical steps. These steps should be very much correct. Our argument should be very much logical, very much mathematical. It should be some basic facts, some definitions, some results which are already known to everyone. So, and we have to use them like in correct order, in correct, everything should be at its correct place in logical way. and then we should reach to our conclusion. So so then our result is proved. So जब हम अपनी assumption से conclusion तक जा रहे हैं, दरमियान में जब हमने logical steps लेने हैं, तो logical steps वही हों जो हमारी source से, assumption से conclusion तक हमें lead करके ले जाए. I mean, we cannot put some steps, although they are correct, but those are irrelevant. So we don't need any irrelevant steps. It's just like if you are going from your home to your university. So you will take those steps, those routes, which will lead you to university, which will lead you to your destination. आप कोई और ऐसा step नहीं लेंगे कि you are going in the opposite or irrelevant direction. So आप वही direction लेंगे, वही routes लेंगे, which will lead you to your destination. So over here also, when we start from our assumptions, some basic, I mean, whatever we are assuming, and we have to go reach to our conclusion. So we will take only those steps, those logical mathematical steps, which will help us to reach to our conclusion. So let's start with some example. And we will start from some basic example. Actually, the proofs that these days, like we are sitting in now 2020. So if some proofs are someone is doing some proof these days, so those proofs might be very complicated. वो proofs कुछ इतने simple आसान नहीं होंगे, क्योंकि जो simple or basic facts हैं, those have been proven long time ago. I mean, this our scientific process. I mean, it has thousand of years of history. So, जो बिल्कुल basic से facts हैं, जो हम for granted ले लेते हैं, उनको proof किए हुए hundreds and thousands of years हो चुके हैं. So आज जो problems होंगे, आज जिन problems का proof हो रहा होगा, those would be quite complicated problems, and the proofs might take something like I mean, it could be some short proof, but some proofs may take like hundreds of pages. So those proofs become quite complicated, quite complex proofs. Like to reach those complicated proofs, we should know the ABC of proofs, some basics of proofs, like 2 + 2 = 4. This when you start your maths from grade 1, you don't start with calculus or trigonometry or differentiation, integration. So start नहीं करते. You always start with like 1 + 2 = 3 and 2 × 2 = 4. इस तरह की basic चीजों से. So proofs सीखने के लिए we will start from the very basic steps. So these statements, these theorems are well known to us. लेकिन हम देखते हैं कि उसको हम एक formal तरीके से कैसे लिखते हैं. Proof writing is a very formal way. उसमें आप कोई चीज skip नहीं कर सकते, कोई चीज आप गलत नहीं लिख सकते. Everything has to be in order and in very logical steps. So let's start with one first example. The example is, give a proof of the statement. If we have a statement that if n is an even number, then n square is also even. We know this thing, even number को अगर आप even number से multiply करें, we will get even number. So n into n, even number into even number, it should be an even number. So if n is an even number, then n square should be even. सबसे पहले तो हमें पता होना चाहिए कि even number कौन से होते हैं, odd number कौन से होते हैं. Even number, we all know even numbers are those which are multiple of 2. Multiple of 2 are called even number, or if some number is not multiple of 2, then it is going to be odd number. So even numbers को हम लिख सकते हैं. If a number is even, let's suppose n is our number, so n is equal to 2k. N is equal to 2k is an even number where k is any integer. So for example, numbers like 0, 2, 4, 6, and on negative side -2, -4, -6, -8. So these numbers are even numbers because these are multiple of 2. और अगर even number में आप 1 add कर दें, so these will become odd numbers. Odd numbers are not multiple of 2. So odd numbers को अगर आप 2 से divide करें, so we will get 1 as remainder. जैसे 3 है, so 3 को 2 से divide करें, so we'll get 1 as remainder. So any number जिसका remainder 2 से divide करने पे remainder 0 है, it's an even number. If remainder becomes 1, so it is an odd number. So odd numbers are not multiple of 2. So n is equal to 2k plus 1. So k could be any integer. So these are odd number. So in general we write even number as multiple of 2. या मैं इसको 2k कह रहा हूँ, k is an integer. और odd numbers को हम लिखते हैं 2k plus 1. आप इसको 2k minus 1 भी लिख सकते हैं कि even number में से आप 1 subtract करें, still it is odd number. So even numbers के दरमियान गैप 2 का होता है और odd numbers के दरमियान गैप भी 2 का होता है. 3, 5, 7, 9 तो दो नंबर का गैप होता है. So किसी भी even number में आप 1 को add कर लें, जो 1 subtract कर लें, we will get odd number. So this is a definition of even and odd numbers that we know from our early school maths. So now let's try to prove this statement. If n is an even number, then n square is also even. So you see, this is an implication. If n is an even number, so n is even number, this is P statement, hypothesis. Then we have to get conclusion that n square is even. So n is even implies n square is even. Okay, so if if we say our statement P is n is even number and statement Q is n square is even, how to prove it? So we start from our P statement, our hypothesis. So let n is equal to 2k. So this is an even number. Let n is equal to 2k. So we have an even number. So we take its square, n square. So n square is going to be 2k square. N is 2k. So n square is 2k square. 2k square is 4k square. And we see 4k square is multiple of 2. So this is 2 times 2k square. So 2k square का हम नाम दे देते हैं k prime का. आप कोई भी variable नाम दे सकते हैं. You can write down is 2 times a, 2 times b, 2 times c, 2 times x, कुछ भी नाम दे दें. मैं k prime का नाम दे रहा हूँ. So 2 times k prime. K prime is equal to 2k square. So this is a multiple of 2. N square is a multiple of 2. So it means n square is an even number. So hence proved. जो हमने prove करना था result कि अगर n even number है तो n square भी even होगा. So it is proven. इसी तरह की एक और example करते हैं. So we need to give proof. If n is an odd number, then n square is odd. पहले क्या था? If n is even number, then n square is even. If n is odd, then n square is odd. We know odd number into odd number is an odd number. हमें पता है इसका. So let's try to show it. So n is odd number. So n can be written as 2k plus 1. And we have to show कि n square भी odd होगा. So n is odd number. N is equal to 2k plus 1. Then n square is going to be, n square is 2k plus 1 square. So we can use formula a plus b whole square. A plus b whole square क्या होता है? A square plus 2ab plus b square. So 2k plus 1 whole square. So 2k whole square is going to be 4k square. 2 times 2k plus into 1. So 2 times a into b. 2 times 2k into 1 is going to be 4k. And then plus 1. 1 square is 1. So over here we can see we can take 2 as common. 4k square और 2 into 2k. जहाँ से हमारे पास 2 कॉमन आ सकते हैं. प्लस 1 वी नीड प्लस 1 क्योंकि हमारा जो स्टेटमेंट था कि n स्क्वायर शुड बी ऑड और ऑड नंबर की शक्ल क्या होती है? 2 टाइम्स समथिंग प्लस 1. 2 टाइम्स समथिंग प्लस 1. So over here we can see 2 times something and then plus 1. So it is 2 times k prime plus 1. 2 times k prime plus 1. K prime की वैल्यू क्या है? 2k square plus 2k. So 2 times something plus 1. So this is a form of odd number. 2 times something. 2 times something is even and then plus 1. So it becomes odd. So n square is not a multiple of 2 because we have plus 1. So it means that n square is an odd number. So hence proved. This is something we wanted to show, we wanted to prove. So if n is odd, then n square is odd. So some basic notations ये आपको पता होनी चाहिए. So n is set of natural numbers. natural numbers हमारे पास होते हैं 1 2 3 4 5. Those positive integers are called set of natural numbers. Z is set of integers. So integers आपके पास positive भी हो सकते हैं, negative भी हो सकते हैं, neutral integers 0 भी हो सकते हैं. So माइनस से लेके 0 और फिर आगे positive integers, in सब का set is set of integers is represented as this, I mean, bold letter Z. Set of positive integers, so we just use plus sign with Z, so Z plus set of positive integers. It means 1 2 3 4 5 6 7 8, इसमें 0 नहीं आता. Set of negative integers, -1 -2 -3 -4, इसमें 0 नहीं आता. So R is set of real numbers. जो आपकी number line होती है is real number line. So real number में आपके integers भी आ जाते हैं, positive, negative, and we have decimal numbers in points. वो सब आपके पास set of real number आ जाते हैं. कोई भी जो हम number daily life में use करते हैं is real number. Q is set of rational numbers. Rational numbers, if you remember, so it's written as in the form of fractions, P over Q. जहाँ पे P और Q हमारे पास integers होते हैं. So rational numbers are those numbers which can be expressed as ratio of two integers. जो हमारे simple integers होते हैं, these are all rational numbers क्योंकि इनके denominator में by default 1 होते हैं. So when we write 2, so 2 means 2 over 1. 3 means 3 over 1. -4, so -4 means -4 over 1. So by default उनके denominator में 1 होते हैं. So we don't need to write 1 in denominators. It is understood. So जितने भी integers होते हैं वो rational numbers होते हैं. इसके अलावा कोई भी number जैसे 2 over 3 है, 3 over 4, 5 over 6, 7 over 10, इस तरह का कोई भी number होगा. So these all are rational numbers. So rational numbers जिसको हम ratio of two integers लिख सकें. I is set of irrational numbers. Irrational numbers जिनको हम P over Q की शक्ल में नहीं लिख सकते, इसको हम fraction की शक्ल में नहीं लिख सकते. So these numbers are like pi. Pi is a irrational number. So 3.1489. So इस तरह वो चलते हैं 3.14 और 27 and so on. उसको हम 22 over 7 से approximate कर रहे होते हैं, but 22 over 7 is not pi. Pi की I mean the exact value, it's like it goes it keep on after decimal point it keeps on going till infinite numbers. Similarly for we can say under root 2 is irrational number, under root 3 is irrational number. तो इस तरह के नंबर जो है वो इनको fraction की शक्ल में नहीं लिख सकते. Just be careful, never write under root 2 over 2. So this become a rational number. So it will remain irrational number. So अगर आप fraction की शक्ल में irrational number involve करके लिखेंगे, they won't become rational number. Rational number में ज़रूरी है कि आपके ऊपर और नीचे denominator, numerator, P over Q, वो दोनों नंबर आपके integers होने चाहिए, right? So I is set of irrational number. So if Q और I आपस में disjoint sets हैं, कोई नंबर एक ही टाइम पे rational और irrational नहीं हो सकता. So if we take union of Q and I, it becomes real numbers. हमारे पास तमाम real numbers आ जाते हैं. C is set of complex numbers. So complex numbers are 2D numbers in two-dimensional on the surface, on the plane. जो आपके पास जिसमें imaginary part आ रहा होता है. For example, 2 plus 3 iota, इस तरह के number complex numbers कहलाते हैं. So these are some basic notations. Some more notations. So you should always remember even number हमने अभी discuss किया. Even numbers are multiple of 2. So we can write down even numbers as n is equal to 2k. Odd numbers which are not multiple of 2 means इनको अगर 2 से divide करें, so we will get a remainder 1. या आप even number में 1 add करें, so you will get an odd number. So in general, n को अगर 2 से divide करें, we get a remainder 1. So n is equal to 2k plus 1 is odd number. Factorial. So we have been using factorials so many times when we are doing counting. So n factorial is n times n minus 1 times n minus 2 going down till 1. So this is n factorial. Perfect power are those numbers जिनको हम किसी नंबर की पावर की शक्ल में लिख सकें. So a and b are two numbers, so n is equal to a raised to power b. These are perfect powers. So for example, we can say 4 is perfect power, so because 2 raised to power 2, 4 is perfect power. Similarly, we can say like 3 raised to power 2 is perfect power, 9 is perfect power. या हम कुछ 2 raised to power 3 कर सकते हैं. 8, 2 raised to power 3 is 8, it's perfect power. या 3 raised to power 4 is going to be perfect power. 3 raised to power 4 is 81, so it's perfect power, and so on. So these are all perfect powers, जिनको हम लिख सकते हैं a raised to power b. So these are called perfect powers. So perfect powers के अंदर we can define like perfect squares. So those numbers which can be written as squares, जिसमें आपके पास पावर जो है वो 2 होती है. So perfect squares are perfect powers, लेकिन ज़्यादा स्पेसिफिक हमने कर दिया कि हमने सिर्फ पावर 2 ले ली. So इसमें सिर्फ पावर 2 वाले नंबर हम ले रहे हैं. So perfect square are these numbers. N is equal to a square. So it could be like 2 square, 3 square, 4 square, 5 square. So 1 square. So 1, 4, 9, 16, 25, 36, 49. All these are perfect squares. Similarly, we can define like perfect cube. So perfect cube are those numbers which are cubes of some other numbers. So n is equal to a cube. So like 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125, and so on. So those are called perfect cube. So perfect power जिसको हम एक नंबर को किसी दूसरी नंबर की पावर में लिख सकें. And this is quite important thing we should know, although we know it from high school. So just we repeat it. Any number can be written as, any number n can be written as n is equal to mq plus r. किसी भी नंबर को mq plus r की शक्ल में लिख सकते हैं, where m कि हम n को हमने m से डिवाइड किया, नंबर n को हम एक और नंबर m से डिवाइड कर रहे हैं. So we should get some quotient and we should get some remainder. सिंपल डिवीजन जो हम करते हैं, आप किसी भी नंबर को जो आपका डिवीजन का साइन होता है उसके अंदर रखें, m डिवाइजर को बाहर रखें. So we will get q quotient and r remainder. अगर तो पूरे पूरे डिवाइड हो रहा है तो r की वैल्यू 0 हो जाएगी, रिमाइंडर हमारे पास 0 हो जाएगा. So in general we can write it down. So if we have a number n, so we can write it down, n is equal to mq plus r. So इसको हम किस तरह लिखते हैं, n को हमने m से डिवाइड किया, so we will get some quotient. Q is quotient. So Q is okay. Q is quotient and we get remainder r. तो जब भी हम किसी नंबर को डिवाइड करेंगे we will get some quotient और कुछ remainder हमारे पास आ जाएगा. So we can also write it down कि m को अगर आप दूसरी साइड पे q से मल्टीप्लाई कर लें, so we will get n is equal to mq, और अगर q रिमाइंडर है तो we have to add that remainder into it. अगर पूरा पूरा डिवाइड हो रहा है तो r की वैल्यू 0 होगी, so n is equal to mq. अगर पूरा पूरा डिवाइड नहीं हो रहा तो we have to add remainder in it. For example, so we can see 12 over 4 is equal to 3. So 3 is quotient. So and remainder is 0. जहाँ पे हमारे पास remainder कुछ नहीं बचता, so we will write and remainder r is equal to 0. So we don't get any remainder. So 12 over r, so n is equal to 12, m is equal to 4, and q is equal to 3, and r is equal to 0. So n is equal to 12, m is 4, q is 3, r is 0. So we can write down 12 as n into m plus r, m into q. So n is equal to 12 is n is equal to m into q plus r, 4 into 3 plus 0. Similarly, we can see another example. If value of n is 15. So 15 divided by 4. अब ये पूरा पूरा divide नहीं हो रहा. So 15 divided by 4 is equal to 3 quotient, and then we have remainder 3, because it will be 3 point something. So we can, if we are just dealing with integers, we don't go into decimal values. So 3 is quotient and r is remainder. So we can write down n is equal to 15, m is equal to 4, q is equal to 3, and r is equal to 3. So we can write down 15 is equal to n is equal to m times q plus r. 4 times 3 plus 3. 3 is remainder. So 4 times 3 is 12, and plus 3 is equal to 15. So we get 15. So किसी भी नंबर को हम लिख सकते हैं n is equal to mq plus r. किसी भी integer number को we can always express when n is divided by m. So it can be written as n is equal to mq plus r. So factorial की बात हुई तो let's try to show this simple fact. Show that 0 factorial is equal to 1. We always use this thing. 0 factorial is equal to 1. लेकिन ये आता कैसे है? Let's try to show it. So factorial की definition हमें पता है, n factorial is equal to n times n minus 1 times n minus 2 times going down till 1. लेकिन इसको हम इस तरह भी लिख सकते हैं कि n into n minus 1 factorial, because n के बाद ये जितनी भी टर्म आ रही है, this is going to be n minus 1 factorial. So I can write it down n times n minus 1 factorial. So what will be n minus 1 factorial? So मैं n को दूसरी साइड पे, इक्वालिटी की दूसरी साइड पे जाके डिवाइड कर सकता हूँ. So this will become n minus 1 factorial is equal to n factorial over n. It will be n factorial over n. So now I can, I can put any value of n and I can get factorial. For example, if I want to have 3 factorial, so this is going to be 4 factorial over 4. So we know 3 factorial is 3 into 2 into 1 is 6. And 4 factorial is 24, divided by 4 is 6. So just in this value, we plug in the value of n is equal to 4 and we get this thing. 3 factorial is equal to 4 factorial over 4 over 6. Similarly, we can move on. 2 factorial क्या होगा? 3 factorial over 3. 1 factorial क्या होगा? 2 factorial over 2. So 2 over 2 is equal to 1. तो इस तरह फिर 0 factorial क्या होगा? This is going to be 1 factorial over 1. This is going to be equal to 1. So 0 factorial is equal to 1. So this is how we get that factorial of 0 is equal to 1. Let's look at some more example. So I give a direct proof that if m and n are both perfect squares, then their product nm is also a perfect square. So this is quite simple. अगर n आपके पास perfect square है और m भी perfect square है, तो n और m को अगर हम multiply करेंगे तो product भी perfect square होगा. Perfect square we remember. So perfect square is square of some number. So if n is perfect square, it means it can be written as square of some other number. M is perfect square, so it can be written as square of some other number. So how to prove it? Let's see. So we have two numbers which are perfect square. So this is given information. कि हमारे पास दो नंबर है m and n. ये दोनों perfect square हैं. So let's write down m is equal to a square and n is equal to b square. A और b की वैल्यू एक भी हो सकती है, different भी हो सकती है. So we are making a generalized proof, so we keep them as different numbers. एक ही नंबर लिखेंगे a square और यहाँ पे भी a square लिख लें, तो फिर तो m और n दोनों बराबर हो जाएंगे ना. So these are two different numbers. So if m is a square, let's write down n as b square. So both are perfect square. So let's look at their product. So m times n. M times n is going to be a square times b square. M की value a square है, n की value b square. So a square times b square. So this can be written as a times b and then whole square. So this is a whole square. This is a perfect square. So we get a perfect square. So m times n, the product is a perfect square. So hence proved. This is something we needed to prove, that nm is a perfect square. So we start from our if statement, our hypothesis statement, and we follow some mathematical facts, some logical step, and we reach to our conclusion, which is required to prove it. Let's do some more examples. Actually, these are easy. You are supposed to do it by yourself, but we can do some of these examples, exercises. So use a direct proof to show that sum of two odd integers is even. These are some basic things that we already know, that uh, even plus even number is going to be even. Odd and odd are, if we add them, odd plus odd is equal to even. This is 3 plus 5, 8 hota hai. So odd plus odd is even, and odd plus even is odd. So these are some basic things that we know, but we should prove it. So sum of two odd integers is even. So let the two odd integers be. So let's take n1 is equal to 2k1 plus 1. K1 is some number, some integer. So two odd integers. So usually we write in 2k plus 1, लेकिन दो numbers हैं तो हमने different लेने हैं, तो a को आप k1 कह लें, दूसरे को k2. So n1 is 2k1 plus 1 and 2 is 2k2 plus 1. आप k1 k2 की जगह कोई और वेरिएबल भी लिख सकते हैं, xy लिख सकते हैं, a भी लिख सकते हैं. So n1 will be 2x plus 1 and n2 will be 2y plus 1. It's perfectly fine. So यहाँ पे मैंने k1 और k2 की terminology use की है. So n1 is equal to 2k plus 1, 2k1 plus 1, and 2 is 2k2 plus 1. So then their sum is n1 plus n2 क्या होगा? 2 times k1 plus 1, n1 की वैल्यू आ गई, plus 2 times k2 plus 1, n2 की वैल्यू आ गई. And over here we can add 1 and 1. So it will become 2k plus 1 plus 2k plus 2 plus 2. So over here I can see I can take 2 as common. अगर दो को common लेते हैं, so it becomes 2 times k1 plus k2 plus 1. So it's 2 times something. 2 times something is even number, multiple of 2. क्योंकि k1 कोई number है, k2 कोई number है, plus 1 कोई number है. So इन तीनों को add करेंगे, we will get some number. वो number जो भी होगा, when it gets multiplied by 2, so it will become an even number. So 2 times some number is even number. Let's call k1 plus k2 plus 1 as k prime. So 2 times k1 plus k2 plus 1 is equal to 2k prime. So it's multiple of 2. So it's an even number. So this is something we were supposed to prove. So hence it proves our result. What we were supposed to prove, that sum of two odd number is equal to an even number. Let's do one more example. So I think these you can do by yourself. Use a direct proof to show that sum of two even integers is even. So पहले जिस तरह हमने दो odd number लिए थे, we can take two even numbers. So let's suppose n1 and n2. So these will be 2 times k1 और दूसरा number 2 times k2. उनको ऐड करेंगे, so we will get 2 times k1 plus k2. So it will be multiple of 2. So it will be an even number. So show that the square of an even number is an even number using direct proof. So हमारे पास एक even number है, n is equal to 2k. So उसको square ये हम कर चुके हैं. That was the first proof that we did. कि किसी भी even number का अगर आप square लें तो वो even number ही होता है. Okay, so this was about proving. Direct proof की एक और शक्ल होती है जिसको हम proof by counter example कहते हैं. We can also call it as disproving. आपके पास कोई claim दिया हुआ है, उसको आप disprove कैसे कर सकते हैं? एक claim दिया है कि ये चीज हमेशा ऐसी होगी. We can disprove it by just giving a counter example. See, it is not always like this. There is something which counters your claim. कोई एक चीज ऐसी है, एक एग्जांपल ऐसी है जो आपके क्लेम को काउंटर कर रही है, उसके खिलाफ जा रही है. So this is called proof by counter example, or we can also say disproving by counter example. So जो आपके क्लेम है उसको हम प्रूफ नहीं करते, बल्कि हम कोई ऐसी काउंटर एग्जांपल दे देते हैं जिससे वो आपके क्लेम डिस्प्रूव हो जाता है, आपके क्लेम गलत हो जाते हैं, रॉन्ग हो जाते हैं, फॉल्स हो जाता है. Let's do some example. So first example is show that the statement every positive integer is sum of the squares of two integers. So this is false. So हम इसको कैसे false show कर सकते हैं? एक काउंटर एग्जांपल देने से जिससे ये क्लेम गलत हो जाए. Every positive integer is sum of squares of two integers. कोई भी आप नंबर लें, so you can always write it down as some squares. यानी n can be written as a square plus b square. So claim is n can be written as a square plus b square. इसका okay, let's write down this claim. So claim is any number n can be written as a square plus b square. So this is sum of two two perfect powers. So this is sum of two perfect powers. Claim is n is equal to a square plus b square. For example, अगर हम 1 को देखें, 1 can be written as a sum of squares. So yeah, 1 square plus 0 square. 0 भी एक integer है, so 1 square plus 0 square. 1 plus 0 is equal to 1. 2 को हम लिख सकते हैं 1 square plus 1 square. 1 plus 1 is equal to 2. 3 को हम नहीं लिख सकते. 3 के लिए we cannot write, for example, if we take 0 on one side, a square 0 आ जाएगा, लेकिन 3 is not a perfect square. So 1 plus 2, so 1 is perfect square plus 2 is not perfect square. So 3 cannot be written. So 3 is a counter example. So 3 एक integer है जिसको हम a square plus b square की शक्ल में नहीं लिख सकते. अगर आप इससे आगे जाएं, 4 can be written as like 2 square plus 0 square. 5 can be written as 2 square plus 1 square. 6 I doubt 6 cannot be written. 5 plus 1, 5 is not perfect square. 4 plus 2, 2 is not perfect square. 3 plus 3, 3 is not perfect square. So 6 is also a counter example. A counter example, I mean, we can give many counter example, but usually अगर हम एक counter example दे दें, so it is enough to disprove the claim. क्योंकि claim एक general claim दिया हुआ है कि हमेशा ऐसे होगा कि every positive integer is sum of the square of two integers. So हम इस claim को falsify कर सकते हैं by giving at least one example. So 3 is one counter example, so it's enough to give this example. एक counter example काफी होती है disprove करने के लिए. So over here the claim is all rectangles are square. जितनी भी rectangles है वो square है. It's not always true. तमाम rectangles square नहीं होती. So one counter example is आपके भी एक rectangle बना लें जिसकी width or height बराबर ना हो, so that would be a counter example. So here it is a counter example कि इसकी width or height बराबर नहीं है. So this is a rectangle but it is not square. So this is a counter example. All squares are rectangle, that is true. जितने भी square होते हैं वो rectangle होते हैं, but all rectangles are square. This is not true. So counter example क्या होगी? Simply just make a rectangle which is height is not equal to width. So similarly we can have more claims and their counter examples. Claim is all prime numbers are odd. जितने भी prime numbers होते हैं वो odd होते हैं. So we know this is not true. The first prime number 2, so 2 is a prime but it is even, it is not odd. So 2 is a counter example. 2 is a prime number but it is not odd, it is even. So 2 is counter example for this thing. इसके बाद 2 के बाद जितने भी प्राइम नंबर हैं वो सारे ऑड होते हैं, लेकिन जो पहला आपका प्राइम नंबर है वो ऑड नहीं है. अगर क्लेम इस तरह हो कि ऑल प्राइम नंबर्स एक्सेप्ट 2 और ऑड, देन इट वाज ट्रू. लेकिन जहाँ पे इस तरह की बात नहीं कि ऑल प्राइम नंबर्स आर ऑड, सो 2 इज ए काउंटर एग्जांपल. नेक्स्ट इज फॉर ऑल इंटीजर्स a and b. जितने भी इंटीजर्स हैं a and b, अगर a b को डिवाइड करता है, a divides b, so please be careful for this notation. a divides b, इसको हम पढ़ते हैं a divides b. ये जो वर्टिकल बार है ये डिवाइड्स का सिंबल है कि a b को डिवाइड कर रहा है. इट्स नॉट a divided by b. A divides B कि A B को पूरा पूरा divide करे. And at the same time, if B also divides A, B भी A को पूरा पूरा divide करे. So we claim that A is equal to B. जैसे आप दो इंटीजर लें, if 2 divides 4, 2 divides 4, that's true, but 4 does not divide 2. 4 divides 2, it's wrong. So we have to take those two numbers which can divide each other. If they can divide each other, then it means A and B they has to be equal. Like 3 divides 3. अगर A और B दोनों की वैल्यू 3 है, so 3 divides 3, and B divides A, so 3 divides 3. So it means A and B has to be same. So we have to give some counter example. कौन सा नंबर ऐसे होंगे कि जो एक दूसरे के बराबर नहीं हो और वो एक दूसरे को डिवाइड भी कर रहे हो. अगर वो नंबर बराबर है, then obviously A will divide B and B will divide A. So be careful for the notation. A divide B, so it means A divides completely B. It's not A divided by B, it's A divides B. A divides B completely. So keep in mind, it is not A divided by B. वो कुछ और चीज होती है. A divided by B, उसको हम इस तरह लिखते हैं. उसमें जो आपकी ये बार होती है, it is going to be slanted bar. So it's like slash. This is called slash, slanted slash. So A divided by B. जबकि ये क्या है? A divides B. A B को पूरा पूरा divide कर रहे हैं. A divides B. So please ये notation याद रखिएगा. इसको आप don't mix it up. ठीक है? So we have to give counter example for this claim that A divides B and B divides A. A B को पूरा divide कर रहा है, B पूरा A को पूरा divide कर रहा है, then A is equal to B. So we can see if we take A and B two numbers, A is equal to 2 and B is equal to -2. In that case, A divides B completely and B divides A completely, but A is not equal to B. So अगर हम A को ले लें, so if A is equal to 2 and B is equal to -2, so in that case A is not equal to B, जबकि A divides B completely. 2 divides -2, now we will get answer -1, and -2 divides 2, so we will get the answer again -1. So ये दोनों एक दूसरे को पूरा पूरा divide तो कर रहे हैं, but they are not equal to each other. So A is not equal to B, 2 is not equal to -2. So this is a counter example. Similarly, we can think of 3 and -3, 4 and -4, 5 and -5. कोई से भी दो नंबर्स जो एक दूसरे के एडिटिव इनवर्स हैं, रेसिप्रोकल हैं, एडिटिव रेसिप्रोकल हैं, एडिटिव इनवर्स हैं. सो उसमें A डिवाइड B होल्ड करते हैं, B डिवाइड A होल्ड करते हैं, लेकिन A is equal to B होल्ड नहीं करते. So this is counter example for this thing. So these are two methods. One was direct proof, the other was proof by counter example. So always remember, जब भी हम proof कर रहे होते हैं उसमें हम कोई illogical step नहीं कर सकते. Illogical step करेंगे तो we may get some illogical results. For example, we try to prove that 1 is equal to 2. So we know this is illogical thing. 1 is not equal to 2. So if here we will follow some mathematical steps, and in between some these steps we did something wrong and we get some illogical results like 1 is equal to 2. Let's see kis tarah. So I mean, you have to figure it out, which one is wrong step, which one is illogical step, mathematically wrong step. Suppose हम दो नंबर लेते हैं A और B और दोनों बराबर हैं. They are positive integers equal to each other. I mean, A, for example, A की value 3 है, B की value भी 3 है. So we can write it down. A is equal to B. So A और B दोनों बराबर हैं. So A is equal to B. Let's multiply both sides by A. So A becomes A square, B becomes A times B. So A square is equal to AB. That's fine. We subtract B square from both sides. So this becomes a square minus b square, and other side becomes ab minus b square. So we subtract something like b square from both sides. Equality holds. Equality पे कोई फर्क नहीं पड़ेगा. So इस a square minus b square इसको हम फैक्टराइज कर सकते हैं. A square minus b square is going to be equal to a minus b times a plus b. A square minus b square is a minus b times a plus b. और ab minus b square, b को कॉमन ले लें. So this become b times a minus b. So we factor both sides. That is fine. We can right side पे भी a minus b है, left side पर भी a minus b है. So we can divide both sides by a minus b. A minus b को काट दें दोनों साइड से. Divide both sides by a minus b. So we will get a plus b is equal to b. लेकिन a तो b के बराबर है from the first step. A is equal to b, so we can write it down as b plus b. B plus b is 2b, so 2b is equal to b. We can cut b on both sides, so this becomes 2 is equal to 1. So we have got some wrong result. It means in this process, जितना भी हमने प्रूफ का प्रोसेस किए हैं, इसमें हमने दरमियान में कोई गलत स्टेप, इलॉजिकल स्टेप लिया है, जिसकी वजह से हमारे पास एक गलत रिजल्ट 2 is equal to 1. It's illogical. We cannot say 2 is equal to 1. इस तरह की चीज आ गई. So we have to identify which one is the wrong step. So I hope you can do it. Okay, I just tell it. So यहाँ पे ये कह रहे हैं कि divide both sides by a minus b. अब a minus b क्या है? A is equal to b. So a minus b is equal to 0 in fact. So it means we are dividing by 0 on both sides. A minus b is going to be 0 क्योंकि a is equal to b. So a minus b is 0. We cannot divide by 0 on both sides of an equality. So this will give some wrong result, some ridiculous result. Because अगर यहाँ पे आप देखें a minus b, हमें अब पता चल गया a minus b 0 है, और यहाँ पे भी a minus b आ रहा है. So a minus b times a plus b is equal to b times a minus b. 0 times something is equal to some other thing times 0. 0 times something is 0. So it's just like अगर आपके पास एक साइड पे 10 है, 10 को आप 0 से मल्टीप्लाई करें, दूसरी साइड पे आपके पास 1 million है और उसको आप 0 से मल्टीप्लाई करें, both sides will become 0, but it doesn't mean कि आप 0 को काट दें और you say कि 10 is equal to 1 million. We cannot divide by 0. It's mathematically wrong step. You cannot divide by 0. So a minus b से जब हमने डिवाइड किया दोनों साइड पे, तो वो हमने एक मैथमेटिकली रॉन्ग स्टेप लिया, और ये मैथमेटिकली रॉन्ग स्टेप लेने से हमारे पास एक अजीब तरह का रिजल्ट आ गया, 2 is equal to 1. So always remember, we cannot take any mathematical wrong step. अगर हम wrong step लेंगे तो हमारे पास फिर results भी काफी illogical से आ सकते हैं. We have to be careful. Here are some definitions, some terminologies that we should know. Theorems are our important propositions that we are going to prove. जो चीज हम प्रूव करने जा रहे होते हैं, जो क्लेम हम प्रूव करने जा रहे होते हैं, उसको हम थ्योरम कहते हैं. सो पहले हमारे पास एक क्लेम होता है, उसको हम कंजेक्चर कहते हैं. कंजेक्चर को जब हम प्रूव कर लेते हैं, सो इट बिकम्स थ्योरम. सो थ्योरम इज अ स्ट्रॉन्ग स्टेटमेंट विद अ प्रूफ. थ्योरम का हमारे पास प्रूफ होना चाहिए. When we have a proof, then it becomes theorem. Lemma are also theorems, लेकिन these are some supporting theorems. जो हम मेन थ्योरम प्रूव करने जा रहे हैं, उसको सपोर्ट करने के लिए हम कुछ और थ्योरम्स यूज करते हैं. सो these are called lemma. So theorems के अंदर हम जो theorems यूज करते हैं, those theorems are called lemma. प्रूफ के अंदर जो theorems यूज करते हैं, उसको lemma कहते हैं. Corollary are some propositions which are obvious from our proof. एक हमने थ्योरम प्रूफ किया, उस थ्योरम से कुछ रिजल्ट्स के लिए हमें नजर आ रहे हैं कि अगर ये होगा तो ऑब्वियसली ये भी होगा. So we take some few logical steps and we get some other results. So those other results are called corollary. So these are not so much strong. These are not the fundamental results. These are those results which are deduced from our main theorems. So these are called corollaries. So theorem, lemma, corollary, ये literature में आपको अक्सर नजर आते हैं. So you should know theorem क्या होता है, lemma क्या होता है और corollary क्या होता है. In proofs, never to do things, never do these mistakes, never do these mistakes. So usually when we are doing proofs, so we are giving a generalized proof. So जब भी proof हम करते हैं ये generalized proof होते हैं. So never take some numerical values to prove कि आपने एक statement proof करनी है, sum of two even number sum of two even numbers is even. तो आप ये नहीं कर सकते कि आप दो even number ले लें 2 और plus और 4. 2 is even number, 4 is even number. So you say देखें 2 plus 4 is equal to 6, so it's even number. So we cannot do like this. We always have to give a generalized proof. Proofs are generalized, so never take some particular numerical values. कुछ number एक particular example लेके आप proof नहीं कर सकते. हाँ, अगर हमने disproof करना है, counter example देनी है, तो उसमें हम कर सकते हैं. लेकिन जब हम एक generalized proof दे रहे हैं एक statement का, उसमें हम numerical values, specific numerical values नहीं दे सकते. So similarly, don't take some mathematical wrong supposition. जिस तरह आपने अभी पीछे देखा जहाँ पे हमने एक wrong step लिया तो उससे हमारे पास ridiculous results आना शुरू हो गए. So never take some mathematically wrong suppositions, mathematical wrong steps. Never take it. And avoid circular reasoning. So never use the fact that you are going to prove inside your proof. आपने एक चीज prove करना जा रहे हैं and you are going to use the same thing in your proof, in your steps, logical steps. So I mean the thing that you are going to prove, you are using that in your proof to prove your things. So this become a circular reasoning. So circular, you cannot say circular reasoning works because circular reasoning works. I mean, and this thing become illogical. So जो चीज आपने prove करनी है उसको आप अपने arguments में use नहीं कर सकते. So there are some more exercises. So I expect that you can do these exercises. If you cannot do, then we can do it in next class by ourselves. We can do it by doing together.